hidden beneath our oceans, something is wrong with life. The further down you go, past the sunlight zone, past the twilight zone, the rules of nature have changed. Animals should shrink in the cold, dark, crushing pressure. Instead, they become giants. We've dropped probes into the atmosphere of Jupiter. We have a telescope floating 1 million miles from Earth, sending back images of galaxies that supposedly formed before our sun existed. And yet the deep ocean, sitting right beneath us, covering 71% of our own planet, remains largely unknown. More unknown than the surface of Mars. At the surface, the ocean teems with life. Coral reefs shelter 1/4 of all marine species. Currents carry nutrients across entire hemispheres. Whales, tuna, sharks. They roam a world lit by the sun and driven by its energy. But descend below 200 meters and that world disappears. Light weakens, then fades, then dies entirely. We've crossed into the twilight zone, a vast column of cold, dark water stretching from 200 to 1,000 meters deep. Here, there is no photosynthesis. What little energy exists falls from above. The remains of dead organisms drifting downward in a slow, endless rain. Scientists call it marine snow. It's barely enough to sustain life at all, yet is the foundation that every creature in the deep is built upon. And where survival is this difficult, life is forced to get creative. In the Twilight Zone, every creature faces the same challenge: how to hunt and hide in a world where light is almost gone and food is scarce. Many have chosen to vanish entirely. The glass squid drifts through the twilight, its body almost perfectly transparent, a ghost held together by water. The glass octopus takes this further. Its body is invisible, only its eyes remain. Why so many species take on transparency here is still not fully understood. It may be camouflage, a way to erase a silhouette in the last faint light, or it may be energy. In a world where food is scarce, building pigment costs more than it gives back. Others choose the opposite strategy, not invisibility, but light. Through a chemical reaction inside their own bodies, creatures have produced their own glow, a process called bioluminescence. The firefly squid uses this not to be seen but to disappear. From below, a swimming creature casts a dark silhouette against the faint shimmer above. To hide, the firefly squid's belly is lined with hundreds of tiny light-producing organs, tuning their brightness to precisely match the glow of the water overhead. It erases its own outline. Camouflage built from light. Some species have found a stranger solution entirely. Drifting through these same waters is an animal so unusual that scientists struggled for years to classify it. It has no bones, no shell, no brain. Stretched out, it reaches 50 meters in length, longer than a blue whale, yet is no thicker than a broomstick. This is the giant siphonophore. And it's not one animal, it's hundreds of them, each a tiny clone locked into a single role. Some swim, some sting, some digest, some reproduce. Together they form a single living net, trailing curtains of stinging tentacles through the water, waiting for anything small enough to brush against them. In a place where food drifts rather than swims, the longer the net, the more the darkness delivers. But the Twilight Zone holds more than tricks of light and living nets. Each night as darkness falls, something extraordinary happens. Oarfish, squid, jellyfish, and vast clouds of small fish begin rising toward the surface. Hundreds of millions of creatures ascending through the water column to feed on plankton under cover of night. At dawn, they sink back into the deep, vanishing into the gloom. This vast nightly movement is called the Deal Vertical Migration. It's the largest animal migration on Earth, greater in scale than any herd, any flock, any swarm ever recorded on land. And yet it went entirely undetected until the Second World War. Naval sonar operators began noticing a mysterious false seafloor, a dense layer that appeared on their screens every night and disappeared every morning. They had no explanation for it. Eventually, they discovered that it wasn't the ocean floor at all, it was life. Hundreds of millions of animals moving in perfect unison, rising and falling, following a rhythm as old as the Earth itself. The twilight zone is where the normal rules of life begin to break down, where life builds light to disappear, where billions of creatures rise and fall each night in a rhythm our own technology could not understand. This is where the deep truly starts, the first section of a world we barely understand. Past 1,000 meters, the last trace of sunlight disappears. We've entered the midnight zone, a realm of permanent darkness stretching down to 4,000 meters. There is no dawn here, no dusk, no sense of time at all. Temperatures sit above freezing. The pressure is hundreds of times greater than at the surface. Nothing about these conditions suggests life should exist here, and yet it is here that the deep sea produces some of its most extraordinary creatures. Somewhere in this void, a sperm whale is hunting. At 18 meters long and 57,000 kilograms, it's the largest toothed predator that has ever lived. It has descended over a kilometer on a single breath, navigating by sound alone, emitting clicks that bounce off the walls of the deep and return as a picture of the world around it. It's searching for something specific, something large. The giant squid. This creature can reach 13 meters in length and weigh over 270 kilograms. Its eyes are the size of dinner plates, the largest of any animal on Earth. Its tentacles are lined with razor-edged suckers capable of tearing flesh, and yet for all its size, the giant squid is the hunted. Sperm whales carry the evidence on their skin, circular scars from squid suckers, sometimes 10 centimeters across, mapped across their heads like a record of battles fought. These two animals have been locked in an arms race for possibly millions of years. As a result, the whale grows larger, dives deeper, hunts more efficiently. In response, the squid grows larger, retreating deeper. Size in the midnight zone is not ambition, it is survival. And here is the uncomfortable truth. A living giant squid was not photographed in its natural habitat until 2004. What we know of these animals still comes largely from carcasses and the stomach contents of sperm whales. How large they have grown remains genuinely unknown. Years and years and years of this battle has been pushing both animals towards sizes we cannot predict. The ocean is vast and mostly unsearched. Scientists hypothesize that something down there may have been getting bigger for 20 million years, and we may not have seen it yet. But the sperm whale and giant squid are not alone down here. Sharing this space are creatures stranger than either of them. Take the dragonfish. Most bioluminescence in the deep produces blue or green light, wavelengths that travel furthest through water. The dragonfish produces something different. It generates red light, a wavelength that virtually no other creature in the midnight zone can detect. This makes its glow completely invisible to everything around it, a private searchlight illuminating prey in total secrecy. Other hunters here take the opposite approach. Certain fish here are cloaked in skin so dark it absorbs more than 99% of all light that strikes it. Even the beam of a research submarine aimed directly at them barely reveals their outline. They do not hide in shadows, they become them. Perhaps the strangest predator in the deep is the anglerfish. The female dangles a luminous lure in front of her jaws, drawing prey toward her in the darkness. But her greatest mystery lies not in how she hunts, but in how she reproduces. Males are born with a single purpose: to find a female. When one does, he bites into her body and never lets go. His jaws fuse with her flesh, his organs dissolve, his eyes disappear, until he is nothing more than a small pouch of genetic material permanently attached, kept alive by her blood. It It's one of the most extreme biological arrangements known to science. This is the midnight zone, where two giants have spent countless years turning each other into behemoths of the deep, where a fish has mastered a color of light that only it can see, where even reproduction has been rewritten beyond anything we recognize. "4,000 meters down, we leave the water column and arrive at the bottom. This is the abyssal plain, a habitat so vast it covers more of this planet than all of its land masses put together, and yet almost nothing reaches it. The sea floor stretches in every direction without feature, just cold, flat mud extending for thousands of kilometers. The water temperature sits at 2 degrees Celsius. Food arrives as little more than dust. To survive here, life operates in a completely unique way. Giant isopods move across the sediment, armored, ancient-looking, reaching up to 50 centimeters long. Their relatives, the common pill bugs found in garden soil, measure 6 millimeters. The same body plan scaled up by a factor of nearly 10. Scientists call this deep-sea gigantism, the tendency for creatures of the abyss to grow far larger than their shallow water counterparts. Cold water carries more dissolved oxygen, allowing larger bodies to be sustained. Food scarcity drives animals to store as much energy as possible in their tissue, and with few predators, there is no advantage to staying small. The colossal squid takes this gigantism to its most extreme. The largest invertebrate on Earth, its body alone reaches 4 meters, but stretch its tentacles and the total length pushes past 10 meters while weighing at 500 kilograms. It prowls these depths with the largest eyes of any animal to have ever existed, up to 30 centimeters wide, built not for hunting, but for detecting the one predator large enough to threaten it, the sperm whale. The colossal squid is not alone in taking this strategy to its extreme. Nothing in the abyss has pushed size and patience further than the Greenland shark, reaching 7 meters long, weighing 1,400 kilograms. It's the longest living vertebrate on Earth. Scientists estimate an average lifespan of at least 272 years, with some individuals potentially reaching 500. There are Greenland sharks swimming in the ocean right now that were alive before the first Europeans set foot in Australia, before Shakespeare wrote a single word. They don't reach reproductive maturity until they're 150 years old, and they cannot see. A parasitic crustacean permanently attaches itself to their corneas, clouding their vision to the point of blindness, drifting blind in pitch-black water for 5 centuries. This is the abyssal plain. In this desert of cold and silence, life does not race, it endures. Creatures grow enormous, eat almost nothing, and live for centuries. Time moves differently here, and we've only just begun exploring it. Beyond the abyssal plain, the ocean floor breaks open. At the boundaries where tectonic plates grind against each other, the crust is dragged downward into the earth, carving trenches so vast and so deep they exist in a world of their own. This is the hadal zone, named after Hades, the realm of the dead. It stretches from 6,000 meters down to nearly 11,000. To place that in context, the cruising altitude of a commercial aircraft above your head is roughly 10,000 meters. The bottom of the Mariana Trench is deeper than that. We are now further below the ocean's surface than we fly above it. The conditions here are unfathomable. Pressure exceeds 1,100 times that of the surface. Temperatures are beyond freezing. For any human, this depth means certain death, and yet life here does not merely survive. In some cases, it thrives. Among the most remarkable inhabitants are the snailfish. Fragile, translucent, gelatinous, they look too delicate to survive a rock pool, yet alone the crushing darkness of a hadal trench. Yet they are the deepest living fish ever discovered and the dominant predators of their world. Their cells are packed with a molecule called TMAO, trimethylamine oxide, which prevents proteins from collapsing under pressure. Sharing the trench floor are creatures that take deep-sea gigantism to its furthest point. The supergiant amphipod belongs to the shrimp family found in coastal shallows, measuring a few millimeters at most. Here, they reach 34 centimeters, the size of a guinea pig, swarming across the sediment in vast numbers, consuming anything that sinks. Inside their bodies, researchers have found plastic fibers carried by currents from the surface world. Even here, we have left our mark. But one species carries a secret stranger than that. It possesses an enzyme that can break down wood, converting it directly into sugar. No plant grows here, no wood belongs here, but occasionally a fallen tree drifts out to sea and sinks to the bottom. And when it arrives, this animal can eat it. Deeper still along the trench walls, life thrives in ways we cannot imagine. At hydrothermal vents along the trench walls, life has built itself from sulfur, methane, and dissolved metals. Tube worms, pale crabs, dense colonies of bacteria communize here, powered entirely by the chemistry of the Earth itself. This changes everything. The oldest traces of life on Earth point not to warm, sunlit seas, but to hydrothermal vents like these. Scientists hypothesize that life may not have started in the light. It may have started here, and if it did, the frozen moons of Jupiter and Saturn, which hide vast oceans beneath their crusts, open many questions to what could be living there. And yet, we have barely explored them. For centuries, these trenches were considered the dead zones of the planet. What we found instead was the deepest proof of everything the ocean has shown us on the way down. The deeper you go, the stranger, the larger, and the more extreme life becomes. The deep sea has shown us extraordinary things, and we've barely started looking. Less than 5% of the ocean has been explored. Every descent, every ROV expedition returns with something that breaks what we thought we knew. Giants that barely eat, sharks that outlive civilizations, creatures made of hundreds of animals acting as one. Even among the animals we do know, so much remains unsolved. Why does the Greenland shark take 150 years just to reach adulthood? We understand the forces that drive gigantism in the deep, but we cannot yet explain how far it goes. The giant squid, the colossal squid, the supergiant amphipod, we have found them, yet we cannot entirely explain them. The greatest mystery of all may be what's still hiding in the dark. The arms race between the sperm whale and the giant squid has been pushing both animals towards sizes we cannot predict, in water we have never explored. Whatever that battle has created is still down there. We have not seen it yet, and perhaps that is what makes the deep sea so powerful. Not what we have found, but what we haven't. A world worth exploring, a world worth protecting.